Hi everyone, this is my project about the analysis of portion of the 1994 census. So my motivation was an article by Ron Kohavi and Barry Becker. These two people, they created um, another hybrid model called the decision tree approach, and they used the model called NB tree and actually compared it and actually proved to be better than the naive Bayes approach and another decision tree approach. So when Ron Kohavi published an article, he also released data from the 1994 US Census. And because I was running low on ideas for my project, I decided that's what I would use. So my data came from a machine learning repository, and it was pretty messy. So I needed two files to clean it. So I'll show you my code. So this is for scraping the column names. So when we actually had the JSON, column names were not included. So I had to hunt for them and find them. I used Beautiful Soup. And so found the full string and it's below, and I'll show you if I run it, get this. And what I really need is all this down here that starts with age all the way to the bottom. So, I get out all the column names and I store it. And so this is where my actual project begins. So I have a bunch of libraries here. And I read a JSON. As you can see here, it's very messy. There's this, random lang column, a pair with the bunch of the data. So as you can see, I cleaned it up. I dropped that lang column, and so further on in, I, brought in the columns that I found from the other page onto here, and it's pretty clean now. I got rid of this later on. So right here, this is the cleaned up data. So I worked with my data frame. I get the total number of records, and then I plot it. And as you can see here, there are outliers. I'll show you again. Let me lift it up. So I'll show you again. Runs. There you go. That's the data. I have some more here. Running out of time, so I'm gonna hurry up. These are the correlation coefficients. I run those. Yep, got that. Data normalization. So this is just looking at all the skewness. So let's see. Yeah, so pretty skewed. And then this is with a logarithmic transformation. Yep. And I can go down. This is the transformation of all of the qualitative variables. So I can run this for you. So go here. We go exploring the data. So this will give information about total number of entries, various other interesting things about it. So I clean it. I get dummy variables. I need 103 of them, which is ridiculously large. So here I'm able to plot all of the qualitative variables, see how they are. Now here I get to split the data into training and testing. So let me run this. There you go. Run it again. Oh, run this again. Oh. Now we look at the models. This is just a naive prediction, just used to compare to my real models. So if I look here, there's a train predict, and that's used to compare my two types of variables. So features is all about the qualitative variables, and income is the quantitative variables. And that's a function that I made. So I researched into a lot of the different kinds of models, and one of those is a logistic regression, Gaussian naive Bayes of k-nearest neighbors. I'll show you how that runs, and I use my function that I used there. So did I click run? Oh, yep. See, now it's telling you like how many samples it ran, and let's see. It takes a while, but yeah, we could skip that for now. We'll come back to it later. So these three are a little more advanced. Oh, here it is. So if you look here, these are the performance metrics. Red is logistic regression, and it doesn't perform too well on the training subsets. But when you go to the testing, it is higher than or at least equal to the other two. So that's pretty much the best of those three. Then I go here, the AdaBoost classifier, decision tree classifier, and the SVC. We go down to the performance metrics. You can see that AdaBoost, consistently scores higher than the others. So go to analysis of results, and here we'll be analyzing. We're going to get a beta score, and here is the performance of the model. So optimized is 85.91, which is not too bad. So here we can say what variables in our data helped us most in predicting, and we could use that for our more accurate model. If you come down here, I can show you, so final model trained on full data is 85.91, which is a pretty good amount. So I hope you liked my video. Thanks.